Hey, what is up my fellow mathematicians? We are here with a video of circle and satellite motion IB Physics 1 packet. So let's begin. A bucket of water of mass 2 kilograms is attached to a 0.8 meter long string and spun in a vertical circle. The speed of the water at the top of the circular path is 3 meters per second. Okay, so I always like to start my questions just making a note of the equations that I'm going to use. So I always write them on the side. Here we have the centripetal acceleration formula, which is v squared over the radius. We also have the mac and cheese formula here. The centripetal force equals mass times the centripetal acceleration. And we also have the force of gravity, which is the mass times the acceleration due to gravity here on Earth. Okay, so now to begin this problem, we first have to read the question, what we just did. And usually in this kind of problem, we always solve for the acceleration first, because when it gives you the velocity and the radius of the circle, then it's something else that out of the list to solve. So let's go for the easiest thing first, step by step. So first we're going to start with the centripetal acceleration, and to do that we're just going to write down here the 3, which is the speed, squared over the radius, 0.8, and that will give us the centripetal acceleration, and that will be let's see, divided by 0.8, and that is 11.25. Okay, so our centripetal acceleration here, it's 11.25. And since we already found the centripetal acceleration, now we can find the centripetal force. So usually finding the centripetal acceleration is the first step for the problem, because when we find the centripetal acceleration, we can find the centripetal force. So for that, we're going to use the mac and cheese formula, which is m times AC. So the mass of the bucket is 2 kilograms, so 2 times the centripetal acceleration, and that will be 11.25 here, and that will give us 22.50, and that is our centripetal force, which is the same as the net force, because the net force here, it's going towards the center, and the centripetal force is also going towards the center. So on this kind of problem, these two forces are equal. So let's just write this down here, 22.5. And now we can find the force of gravity, which is the mass of the object, 2 kilograms, times the force of times the acceleration due to gravity. So 2 kilograms times 9.81, 2 times 9.81, and that is 19.62. Let's put it down here, 19.62. And now to find the force of tension, all we have to do is just make a little equation here. I'll do it on the side. Ft plus Fg is the net force, which is 22.5. We already know the force of gravity, so we can just plug that number in here to find the force of tension. So plus 19.62 equals 22.5. Now to find the tension, we can use our algebra 1 skills. Just subtract 19.62 on both sides, and that is easy. 22.5 minus 19.62, and that will give us 2.88. So this is our force of tension. And the direction here, both directions are going down, because as you can see here, the arrows are going down towards the center, towards the middle of the circle. And that was it. That was question A. Now let's go to B. A bucket of water, 2 kilograms, is attached to a 0.8 meter long string and spun in a vertical circle. the speed of the water at the bottom of the circular path is 6 meters per second. Okay, so the first thing that we notice here is that first, the speed here is different, but the rest of the question here is the same, pretty much the same. But what changes here is the direction of the forces. Here, force of gravity is going down, and the force of tension is going up. Why? Because the bucket is at the bottom of the circle. So let's start by finding the centripetal acceleration. We have our formula here, and for that we're going to use the speed, AC equals the speed squared over 0.8, which is the radius, and that will be 6 squared, which is 36, divided by 0.8, and that is 45. So our centripetal acceleration here is 45. And since we already know that the net force equals to the centripetal force, we can just find the centripetal force, and that will give us the net force. So let's write this down here. The mass is 2 kilograms, just like on the other problem that we just did, times 45, and that is 90. So the centripetal force is 90, and so is the net force, because both of them do the same thing. Now we can find the force of gravity. Simple. To do that, it's just the mass times 9.81. And as we did in the other problem, it's going to be 19.62. Now to find the force of tension, we're going to do pretty much the same thing from the other problem, but since it's going in the opposite direction, then the forces must be going to opposite directions, right? So we're going to have our force of tension, Ft, minus the force of gravity, because they are going in opposite directions, which will be equal to 90, the net force. Now we just have to plug in the number for the force of gravity, which is 19.62, which will be equal to 90. So force of tension equals 90 plus 19.62, and that is 109.62. And the acceleration here is going towards the center, centripetal acceleration, so it's going upwards. So is the net force. Okay, so now let's go to question C. A 500 kilogram roller coaster car is at the top of the loop on the shock wave. The radius of the loop is 4 meters and the speed is 8 meters per second. Okay, so this is a very similar problem. What changes is just that the roller coaster, it's just like a bucket, but a bucket with people, not with water. So let's begin just writing down our formulas here that we already know. So the AC, the centripetal acceleration formula, and the radius, the mac and cheese formula, and our force of gravity formula. Okay, so now let's find the centripetal acceleration. To do that, simple, you guys already know. Speed, 8 squared over the radius, which is 4. And that is equal to 8 times 8, 64, right? Let's see. That's right. 64 divided by 4, divided by 4, and that is 16. So our centripetal acceleration is 16. So we can write this down here, 16. And now let's find the net force. The net force is equal to the centripetal force. So we can just solve for the centripetal force that we will find the net force. So Fc equals the mass, which is 500 kilograms, times 16, which is the centripetal acceleration. So 500 times 16, and that is 8,000. So our net force is equal to 8,000 newtons. Okay? Now let's find the force of gravity. force of gravity is 500, the mass, times gravity, 9.81. That is 500 times 9.81, and that is 4,905. Okay. And now to find the normal force, it's simple. We just do the same thing as we did on the other problem. We just add up both forces and equal it to the net force. So we can do Fg plus Fn is equal to Fnet. Why we're adding up? Because both forces are going the same direction. They're not going in the opposite directions. So the force of gravity, which is 5,905, plus the normal force will be equal to 8,000, which is the net force. And now to find the normal force, all we have to do is subtract 4,905 from 8,000. So let's do that real quick. That gives us 3,095. So this is our normal force. And since both arrows are going down, we know that the arrows here are going down, but those arrows are also going down. So yeah, the centripetal acceleration and the centripetal force are going down because that's where the center of the circle is. Okay. So now let's go to question D. As I said before, it's very similar to the other question, to question B, because both forces are going the opposite directions now. And yeah, so let's start figuring out the acceleration. For that, we of course have to read the problem first, right? So a 500 kilogram roller coaster car is at the bottom of a loop on the shock wave. The radius of the loop is 20 meters, and the speed is 24 meters per second. Okay. So the centripetal acceleration is the speed squared over the radius. So we get the speed 24 squared over the radius of the circle, which is 20 of the loop, and that is equal to 24 squared divided by 20. So our acceleration is 28.8. Let's write this down here. Now to figure out the net force, all we have to do is figure the centripetal force. So Fc equals the mass, 500, times the centripetal acceleration, which is 28.8. So 500 times 28.8, and that is 14,400 newtons. And now we can find the force of gravity, and then we can find the normal force. So Fg equals the mass, 500, times 9.81. And that is equal to 500 times 9.81. And that is equal to 4,905. 4,905. Just here, like, because we're having the same mass. So it goes here. Now to find the normal force, you guys already know, it's just the force of gravity minus, the negative. Here, I'll just make it in a better way for you guys to understand better. So it's the normal force minus force of gravity, which will be equal to the net force. We already know what the force of gravity is, so we just have to plug in this number. And we also know the net force, which is 14,400. Now we just have to add 4,905 both sides. and that will give us the normal force. Let's add this number. So we got 19,305. That is our normal force. And to find the directions, it's simple. The centripetal acceleration is going towards the center of the circle, so it's going up, and the centripetal force is also going up. Okay guys, I hope you enjoyed this video. If you liked it, just hit that like button, subscribe if you haven't already, and thanks. See ya.